CRG is a very young institute, and cell biology program is in fact the youngest of the CRG. And in the last 10 years or so that the CRG has been here in cell biology department for about 7 or 8 years, you would notice some amazing discoveries, some amazing molecules, proteins that have been identified and the principles in biology, life sciences that have been discovered here at the CRG are quite remarkable for such a young institute.
So we are a group of primarily biophysicists, and we're interested in biophysical aspects of the cytoskeleton, specifically the microtubule cytoskeleton. And over the years, we've devised experiments in which we can show that dynamic microtubules, growing and shrinking ones, can generate forces, and I will show some of these older data. But we're now also interested in seeing how far we can sort of take these simplified systems and bottom up build something in a confined geometry, which is the topic of today.
Some 10 years ago, people have started to look at the molecular events or structural events that give rise to this newly born centriole. And basically, based on electron microscopy studies, the first structure that appears during procentriole formation is this so-called cartwheel structure, which then assembles the microtubule triple blades around it. So this is a side view of the process, and this is also typically what you find in textbook. Now here you see a representation of the cartwheel based on electron microscopy studies. The cartwheel is characterized by a central hub of 20 to 25 nanometers in diameters. It contains radial spoke and a pinhead structure which connects the cartwheel to the microtubule triplet blades.
The ultimate role of cell adhesion is to enable the self-organizations of cells during the development and the dynamic maintenance of multicellular organisms, such as the zebrafish embryo shown here. Therefore, cell adhesion cannot be a passive process, but has to be a dynamic and tightly regulated process.
Something very interesting because you can get some interactions with the colleague working in your field, so you can always get some ideas, present your work to the different people working in this field and also in different fields, so it's very interesting to get the input from the person and from the people attending and also having questions about your project in general. It's also good because you learn how to explain your project in general like in an easy way, also for the rest of the people to understand even in different fields.
For me, it has a great value because I was here for 4.5 years and I established my project basically here.
It's really nice to be back here. I was a grad student here a few years ago, and so I'm very happy to be back in Barcelona, meet a lot of people and also meet the other speakers.
This opportunity to see a lot of speakers from every part of Europe or the world speaking about the topics that they are expert in this field. For me, it's amazing.
When you organize something like this, you're in touch with the world-leading scientists in very different fields, and you get to know them personally, so that's definitely a plus.
I think it's an opportunity, so every student, and of course for people that has more experience in this field.
What I'll be telling you about today is how important translation speed and specifically codon translation rates are for maintaining your proteome in a healthy state, and how these translation rates are modulated by tRNA modifications.
There were wonderful talks on the technological frontiers of cell biology. Jennifer Lippico-Schwartz delivered a fantastic talk about the super-resolution microscopy. That was really definitely a highlight.
I was very impressed by all the images from Jennifer's talk. It was very nice.
The talk related to the centrosome amplification and its role in cancer, because for me I think it's something also very interesting, and the techniques applied were also very novel, so I think for me it was one of the best that I liked the most.
I think when you do interdisciplinary things is the perfect way to this kind of approaches. So I think I will highlight this kind of speakers that try to take methods from other parts and implement in fields that are always more in the bench, doing things with compounds and things, and try to do more physics, mathematical approaches.